In this video, we'll be looking at the laws of logarithms and working with them. So at this point, I'm assuming that you've already been introduced to logarithms and you already know the basic definition of a log. If not, then watch my previous video as I'm running on that assumption and we're going to start off from that point. So the laws of logs are derived from the laws of exponents. I'm not going to go through that derivation right now, but I just wanted you to know that. So let's write down these laws and then work with them. The first law is that log to the base b of m times n is equal to log to the base b of m. I need to write this a little bit neater because I want you to be able to read it. Alright, log to the base b of m plus log to the base b of n. That's one. Our second law is that log to the base b of m over n is equal to log to the base b. And if you take a look at the first one, you can guess it. M minus log to the base b of n. And our final and third law is that log to the base b of m raised to the k power is equal to k times log to the base b of m. So I call these things on the left side, I call these or single log form. I don't think that's an official name, but I'll tell you why I call it the single log form. Well, as you can see on the left side, there's just a single log. So, hey, there's just one single log on the left. So that's our single log form. And on the right, I call it our expanded log form. Again, it's just my name for it. Now, it's pretty helpful to be able to go back and forth from the single log to the expanded log form. This will help us to be able to solve equations later on, solve problems. You'll see. So let's take a look at a few examples. Okay, so in this example, they're asking us to express log to the base 6 of m squared n to the third in terms of log to the base 6 of m and log to the base 6 of n. So they're basically asking us to change from one single log, so everything is all bunched up into a single log, and they want us to expand it out into separate logs. We can totally do this using our laws of logs, which I put here. And eventually you're going to want to know all three laws of logs, but for now you can check back every time you need them. Alright, so let's do this. We want log to the base 6 of m squared n to the third as an expanded log. Fair enough. So we know from our first rule that if we have two logs being multiplied, then to separate them, to expand them, it will turn into an addition. So that turns into log to the base 6 of m squared plus log to the base 6 of n to the third. And again, that is from rule 1. Alright, but it's not done here because we have exponents here and here, and we don't want them because we're going in our expanded form. So our exponent in the single form going to the expanded form becomes a coefficient. So according to rule 3, this is actually going to be equal to, and so this 2 comes over here and it becomes 2 log to the base 6 of m, and again we move this 3 over here and it becomes plus 3 log to the base 6 of n. And we're done with this problem. Okay, so in this example, we are working from this form, which is our expanded log, and we're going to try to get our expanded log to a single log. So as you can see, the expanded log is on the right side, and so we're working backwards this time to try to get to the single log. Now, let's do a rewrite first. We have 4, let's rewrite that. We have 4 log to the base 10 of p minus 2 log to the base 10 of q equals. All right, so first thing that we want to do, if we want to get it over to the single log, we want to make sure that there is no coefficient here. So the coefficient turns into an exponent when we change it to a single log. So we're taking this 4 and we're turning it into an exponent, and we're also going to take that q and change that 2 and change it to an exponent. So we get log to the base 10 of p raised to the 4th power minus 2 log to the base 10 of q. Well, actually, not 2. We're actually going to change that to an exponent, as we said. So raised to the 2nd power. All right. So now we're getting closer. We just used our third law. So let me just put a little note here. We just used our third law, and we need to now, in order to get it closer to our single form, we need to recognize that here we're doing a subtraction, which means that we're going to have to use our second law, and again we're working backwards, so our subtraction turns to division. So this becomes log to the base 10 of p to the 4th over q squared. And that's how you change back to a single log. Okay, so in this example, we can use logs that we do know to find a log that we don't know. And we use our laws in order to figure that out. So let's see how this would work. The question is asking us to find log to the base 10 of 18. And we know what log to the base 2 is, the base 10 of 2 is, and we know what log to the base 10 of 3 is. So basically, if we can figure out how to make up 18 from 2 and 3, then we can figure out what log to the base 10 of 18 is. So this is if you don't have the calculator, for example. All right, so log to the base 10 of 18. Well, we know that log to the base 10 of 18, I can break that 18 down into 2s and 3s. Let's say in this way, 2 times 3 times 3 would give us 18. Or perhaps 2 times 3 squared, same thing. All right, so now according to our first rule, this is really the same thing as saying log to the base 10 of 2 plus, and I'm separating it, I'm expanding my log here, log to the base 10 of 3 squared. I can expand my log even more by getting this exponent over here, and I have log to the base 10 of 2 plus 2 times log to the base 10 of 3. All right, recall that they actually told us what log to the base 10 of 2 is and what log to the base 10 of 3 is. So we can replace those things. Log to the base 10 of 2 is 0.3 plus 2 times log to the base 10 of 3, so 2 times 0.48. All right, and when we work that out, we get 1.26. All right, that's a handy little thing to know. All right, let's look at one more thing before we wrap up. Okay, so we're going to now look at how to solve an equation using the laws of logs. if you know how to solve this equation, then you really and truly understand the laws of logarithms. All right, so as you can see here, we have our log in expanded form because we have a log over here and a log over here. It would be easiest and most effective if we had one log on the left and one log on the right. So that's what we're going to do. We're going to get a single log on the left and a single log on the right. Okay, so according to our laws of logs, when you have an expanded log with a plus sign, you have to change it to a single log with a multiplication sign. So that's the first law. So let's go ahead and do that. So this becomes log to the base 3 of x times x minus 6 equals. All right, now on the right side, I said we wanted to change this to a single log also. But how do we change 3 to a single log? Well, we do that according to the definition of a log. We're looking, so first of all, we want it to be in base 3 because that's in base 3. So we know that's a solid start right there. So we have, let's do a side note here, log to the base 3 of some number x that we're trying to figure out right now will give us 3. So, and why 3? 3 because that's what we want here. So we want a log that is equivalent to 3. So how do we do this? According to the definition of logs. Well, remember that the base is 3, the exponent is the number over here, and that's our answer. So 3 to the third power will give us x. So 3 to the third power actually gives us 27. And that's a 7. All right. So log to the base 3 of 27 is 3. So our 3 is equivalent to this log. This log is actually equal to 3. So if that doesn't make sense to you, that means you might have to go back and look at the introduction to logarithms video once more. And that's fine. All right. So now that we have a single log on the left side and a single log on the right side, take note of this. This is log to the base 3. This is log to the base 3. This is the log to the base 3 of something. This is log to the base 3 of something. It follows that or something and or something has to be the same something, right? Exactly. So we have x times x minus 6 is equal to 27. These two things have to be the same. All right, so now it looks like a much easier thing to solve without that log there. We have to distribute that x, and we get x squared. Hold on, let's use black. We get x squared minus 6x is equal to 27. Now, what type of equation is this? We see it all the time. The highest exponent is 2, and that tells us that it's a quadratic, which means that we want it to be equal to 0 so we can factor and solve. So on the left side, we get x squared minus 6x minus 27 is equal to 0. So now we're looking for two numbers that multiply to give you negative 27 and add to give you negative 6. Or two numbers are negative 9 and positive 3, which means that x is equal to 9 or x is equal to negative 3. Now, here's the thing. Logarithms are undefined in the negative space. So there can be no negative logarithm, which means that since we have an x here, that would make a negative 3 here, and that's no good. No to that. No, 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 no. But a positive number is perfectly fine. So x is actually equal to 9. And we have solved our pinnacle of laws of logs questions.